Well, good evening, Panther families. My goodness, it feels like it's been forever since we've been able to see you in person today, or this since I guess last Thursday. I hope you're doing well. I'm so proud of how all of our Panthers have been keeping up with their assignments on NTI. And parents who are watching, I just want to say thank you. I know it's an extra burden on you all to make sure that your Panthers are getting on their Google Meets and getting their work done. So just thank you so much for all you're doing to make sure we keep our learning momentum going during this time. And we saw there was a big drop in student performance last year when we had a big closure, we had a big virtual learning time. And so we're trying to do this with this NTI is not to have that loss and to make sure our learning momentum keeps moving forward. So I hope you are ready for a fun night. Hopefully you have your science kit with you. Should be in a plastic bag like this. And I've been looking forward to this for a few weeks. We are going to be joined by Mr. Jason Lindsay, and he is going to be leading us in some experiments. You're going to be entertained, you're going to be educated, and it's going to be just a great time. I will say, as you're watching, hey, parents, take a picture of your kiddos participating and post it on Twitter or Facebook and tag us in it. And if you have questions, there is a chat box on the YouTube channel that you can type a question in there, and I might pop in and ask your questions to Mr. Lindsay. So without further ado, here is Mr. Lindsay. Oh, Mr. Lindsay, hang on just a second. I just see we do not have any audio. So hold on just a moment. Oh, I hear you, but our live stream does not hear you. Let me adjust something real quick. That's something on my end. Okay, making sure audio. Oh, perfect. All right, let's see if we can. All right, give me a sound check there.
Testing 1, 2, 3. Can you hear me?
Okay, now we hear you.
Cool.
Oh my goodness, that was embarrassing. But we fixed it now, so sorry.
Nope.
Man, students, Mr. Lindsay just had the most amazing introduction ever, and hopefully he can replicate it here again. So sorry about that. That was my fault.
I was talking about how the principal at Plano Elementary School smells like cheese. Is that right, boys and girls?
What?
No,
I thought we
no.
talked about this last time. We're not going to talk about the cheese smell anymore.
No. All joking aside, it's the science guy, Jason Lindsay, when I'm talking about cheese. Okay, either way it goes, how are you, friends? I hope you're safe and well as we continue to battle a vicious virus. I just got over it. Yes, I was vaccinated and boosted and still got it, but it was almost like a common cold because of that. So I survived. This is my 7th day after my first symptoms. So everything's good to go. I'm out of quarantine and so on. Either way it goes, I have to remind you of a few things. Don't eat or drink your science experiment. Have an adult around, wear the appropriate safety gear when doing science. We don't need a kid burping up fireballs. It happened once. I remember that time. Okay, I'm joking. It didn't. Also, as we continue to fight COVID, wash your hands often with warm soapy water. Make sure that you keep your fingers away from your eyes, your nose, and your mouth. And if you're sick, stay at home. Don't get out. Okay, with all that stuff out of the way, because I'm tired of hearing about COVID like many of you are, we're going to get to some mind-blowing science experiments. As Mr. Frazier had already mentioned, make sure you're snapping pictures of your kids doing some science experiments. I want you to post those at the Hooked on Science Facebook page. Just look for Hooked on Science on Facebook, HOS Mr. Science on Twitter, and Hooked on Science on Instagram. Post your pictures and your comments, and I'll enter you into a drawing for one of my new science books. It's called Big Science Experiments for Little Kids. So again, all you got to do is post your pictures and your comments at Hooked on Science on Facebook, Instagram, Twitter. Just look for the post, and I'll post it just a few minutes after our live stream. So I'll give you about 24 hours to do all that before I announce the winner. Okay, so I hope you're safe as you have been at home. You've even experienced some snow here in Bowling Green. I'm actually in Bowling Green, and I was in Paducah earlier, where I call home, we had no snow there, but you have what, an inch or two here? Is that what you got, Mr.
About that,
Frazier?
yep. About an inch
Yeah.
and a half, I think.
Pretty cool. So I guess a combination between being sick and snow, you combine them together and you get out for a day. You know, when I was a kid growing up here in South Central Kentucky, there was a place that we would always go sledding, Hospital Hill. Is that still popular? All the kids still go there?
Oh yes, that's the big spot, but that's too scary for me. That hill's way too steep.
Oh, come on, Mr. Frazier. I think everybody should throw snowballs at Mr. Frazier. What do you think? When you go
Okay,
back
we're
to
gonna have a conversation after this again. Cheese
Okay.
and snowballs now. Okay.
No. Okay. Now you have a bag, as Mr. Frazier pointed out. It has ingredients for 2 experiments. The guide is here so you can do this beyond our live stream here. On one side, it tells you how to do the notebook spring launcher, and on the other side, it tells you how to do the levitating ping pong ball. Those ingredients are in your bag. You're going to do those with me. How you know that you're going to need those ingredients? I'm going to say, hey, it's time to do a science experiment with me, Mr. Science. I have 3 other experiments. One to where we're going to create a gassy balloon. Then I'm going to fill this balloon up. It's a punch balloon, and we're going to skewer it. And then we are going to capture a shadow. So we'll turn off the lights and capture a shadow. So we're going to cover lots of concepts here. Light here, usually first graders are covering light, and then you'll master it in 4th grade. Then we're going to hit matter. So for those of you that are in 2nd grade or 5th grade, we hit matter in Kentucky. Then we're going to talk about some pushes and pulls. So that's a kindergarten and 3rd grade concept. A little bit of energy, that would be 4th grade as well when we talk about light. So we're going to cover all of K through 5th and some 6th grade concepts too, because of course in Warren County, those 6th graders are in elementary school, right? And then when you get to middle school, 7th and 8th. So I was born and raised here, as I'd mentioned. I grew up, I was one of those kids that was transient. So I started out at Richardsville Elementary School, then moved to Parker Bennett. Then I went to Warren Elementary, TC Cherry, LC Curry. I went to lots of elementary schools, like 8 different ones, but I ended up
hit
the
them
best.
all.
Yeah, I hit a city and county. I went to the best high school ever, Warren Central. Wait a minute, is that where Plano kids go?
No, we go to South Warren.
South Warren. That school didn't exist when I was here 20 years ago. Not at all. Okay, let's start with capturing your shadow, because that's one of my favorite things. It's all about energy, which is the ability to do work. So let's refocus. Crisscross applesauce. Eyes on me. If you're sitting in the floor, good job. Hands in your lap, good job. So what I have here is a bright flashlight, okay? And then I have this right here. It's a board. Now you can create your own. Just take any kind of board that you have around the house, of course with mom and dad around, and you can go to your hardware store, Walmart, Target, paint store, any place, and get glow-in-the-dark paint and paint the board multiple times, like 20 times with glow-in-the-dark paint. So this is all about energy, ability to do work. Light travels in a straight line until it hits something. Once it hits something, it can do one of 3 things. It can reflect, bounce off of. You see me because light is bouncing off of me. Refract, bend. So if I take a pencil or my fork or a straw and put it in a glass of water, near the top where the water and the outside, the air meet, it looks like it's broken, all because the light is refracting. And then light can absorb, take in. So reflect, refract, absorb. So all 4th graders should know those 3 words. 3 more words and then we'll move on. Light can't get through my board because it is opaque. Light can somewhat get through this because it's translucent, and light can get through the window or my bag because it's transparent. So transparent, translucent, opaque. Okay, enough about all that. Let's get to the fun experiment. I'm going to turn off the light over here, and then I'm going to put my hand on the board, and as I put my hand on the board, I'm going to capture my shadow. So here's the board. I'm going to turn off another light here too, just to make sure we get the best. There we go. I think it's dark in here now. This is almost kind of spooky. Place my hand on here. Bright light. See the bright light? Bright light. Bright light. Eyes on me. Good job. Flat tire. Do you all do that at Plano, Mr. Frazier?
No, we don't do the flat tire.
Okay. I say flat tire. You go, shh. Let's practice. 3, 2, 1. Flat tire. Good job. Okay, got my hand on here. My hand is opaque. Light can't get through my hand. Therefore, it can't get to the board, right? So the board's absorbing the light, taking it in, and it's going to re-emit the light. And that means it's going to glow, basically. Okay, I'm going to move my hand. Let's see if I captured my shadow. Do you see that? Good gravy. I've captured my shadow. Look. Oh, uh-oh. I'm Iron Man. I'm going to put a hole in my hand. There we go. Pretty cool. So let me find several objects here that I have, and I'm going to place them on the board. Again, kids, encourage your parents to paint an entire wall in your living room with glow-in-the-dark paint. I think that's a good idea, right? And then when you do that, you can take a bright light and then capture your shadow, or for that matter, your hand shadow or whatever. Okay, so I have some keys in my pocket. I'm going to grab those, place those on the board. I'm going to grab some stuff from my bag here. There's the dowel rod that you have in there. Oh, the spring. I'm going to place that on here. I'm going to place the straw on here. Why don't we place a balloon on there too? Bright light. Okay. So again, energy, light. The light is reflecting off the red balloon. I see the red because the color red is reflecting from it. There's a yellow straw there. There's a dowel rod. There's my keys. Okay, are we ready? I'm going to remove everything and look at that. Wow, it's like an X-ray machine, isn't it? But it's safe, I promise. It's safe. It's a pretty cool science experiment you can try right there at home with just a few ingredients from around the house. Now, I can erase it all because, again, it's not permanent. So you can't do your homework on this and send it to school because it's going to go away. Keep erasing it. Put this on here, and you'll notice. You see that pretty good? It's neat, isn't it? Yeah, so all this is, now this one here is a vinyl sheet that I have. That vinyl sheet is a lot better than painting a board. It tends to absorb the light a lot better. Either way it goes, you can make it work even when you paint the board with glow-in-the-dark paint. You just have to use a whole lot of paint. A word that we use for a whole lot would be copious, a bunch of, so that you can see it a whole lot overall. Okay, cool. Did you like that one? Thumbs up. Awesome job. Now it's time for you to do a science experiment with me, Mr. Science. Are you ready? I need you to grab some ingredients from your bag. We are going to talk about pushes and pulls. So while you're grabbing these ingredients, we'll talk about it. What I need you to grab from your bag is the bendable or flexible straw and the ping pong ball. So you be grabbing that, place it in front of you, and I'm going to tell you a little bit about a force. A force is a push or a pull. We learn it at a very early age when we're just in our diapers pushing things around. That some things are harder to push than others. For example, it's harder to push a wagon full of rocks than an empty wagon, right? When you get to middle school, you connect that to the second law of motion. Force equals mass times acceleration, more mass, more force, so on. So that wagon stays there until something moves it. Once it starts moving, it keeps going until something stops it. That's the first law. We've talked about the second law. There's one more law of motion. It's called the third law of motion, and it's for every action, there's an opposite and equal reaction. So here's what we're going to do. We're going to add a force to our ping pong ball. Okay, eyes on me. I want to show it to you first before you do it. Okay, so put everything in front of you, eyes on me. Here's what you're going to do. Not yet, not till I say go. Got it? You're going to take your straw and you're going to bend it because it's a flexible straw, right? You're going to make it look like this. See there? Okay. Then you're going to place the straw in your mouth. Now, you wouldn't do this in front of someone's face since we're fighting COVID, right? Well, you can your parents because you're around them all the time. You're going to take your ping pong ball and place it on top. Not yet. Put it down. Okay. And you're going to blow through it and then make the ping pong ball look like it's floating in the air. I told you that I was a Jedi in training. I can make things float in the air. You can too. All you got to do is this. Watch. Now it's your turn. Okay, now parents, this is the time you take pictures of your kids doing this cool science experiment. You're going to post them at the Facebook page there at the Plano Elementary School page as well. And I'm going to enter you into the drawing for the free science, but maybe a science kit too. I don't know. You'll get something. Okay, so it's your turn to do it. I'm going to give you a few minutes to do it, and then we're going to wrap this up and move on. But what's happening is, go ahead, you can do it, and I'll still talk. Uh-oh, Mr. Frazier's trying to do it. What'd you do, Mr. Frazier? Did you drop the ping pong ball? Okay, here you go.
Yep, I dropped it.
He's going to try it one more time. And the coolest principle ever. There he goes. Oh. Yes. Now, you really have to blow hard through the straw. That's key. It may take a few minutes. Kindergartners may take a little bit longer than sixth graders, okay? Either way it goes, you keep practicing. That's what science is all about. It doesn't work the first time. It doesn't work the second time. It may not work the third time, contrary to popular belief. You got to blow really hard through the straw. That's key, okay? Now, we could try different straws. That will be different variables, a big straw, small straw, longer straw, shorter straw, so on, to mix it up just a little bit. A golf ball obviously wouldn't work. It would be too heavy to have more mass. Are you smelling your armpits, Mr. Fraser? No, you're coughing in your armpits. Sorry about that.
Demonstrating the proper way to cough into your shoulder.
Proper way to cough. Sorry about that. Okay, here we go. One more time while you're still trying it. There we go. I'm going to let you try it just for a few more minutes. Now, this is reusable, meaning that this isn't the last time you do this science experiment. You can keep doing it time and time again. And parents, here's how we know that your kid got the science experiment. Anybody can study for a test. Anybody can ace a test if you study hard enough. But how I know your kid has mastered the concept, they're teaching someone else. They're at the lunch table. They're at the breakfast table. They're at the supper table. They're with their cousin. They're with grandma. They're with grandpa and saying, look, hey, watch this. Cool science experiment. Take your straw. Air blowing through this creates a force. It pushes the ping pong ball up. There's another force pulling down called gravity. Where they balance out at is where it floats in the air. That's how we know they've mastered it. Not because they can ace a test, but because they can teach someone else. And they're using everyday ingredients from around the house. Okay, just a few more seconds, and then we're going to wrap that one up. And then we're going to clean up our experiment, and then we're going to move to matter. Matter is a pretty cool subject. It's everywhere. It's all around us. You'd be thinking about I have a joke for you. Why should you never trust an atom? Because they make up everything. Okay, I'll stick with science. Guess I could be a science comedian. I have another joke for you.
If I had a rim shot sound effect, I would have played it right there.
You would have. Awesome. Okay, here's my other joke. Why do ants not get coronavirus? Because they have antibodies. Okay, we better move on. Oh, one more. Where do bad rainbows go? To prism. It's a light sentence. Okay, enough of that. My corny jokes. Okay, put everything away. We're going to refocus. Put everything back in your bag. No playing with it. By the time I get to 1. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Macaroni and cheese. Everybody freeze. Are you frozen? I shouldn't hear you. Good job. Okay, so matter is anything that takes up space and has mass. It can exist in 5 states. Kentucky, Tennessee. Okay, another joke. Solid, liquid, gas, Bose-Einstein condensate, and plasma. So the last 2 you won't encounter unless you're in a science lab somewhere. But the other 3, solid, liquid, gas, we encounter all the time. You want that magical number whenever it's raining outside, because that number, 32 degrees Fahrenheit, makes a liquid like rain go from a liquid to a solid, snow, and you get out of school if there's enough of it, right? That's the key. It seems like Bowling Green's been getting more snow than us over in Western Kentucky, and then Eastern Kentucky's been getting a lot more, like several feet in some cases along the Eastern Kentucky, West Virginia border. Either way it goes, that magical number, 32 degrees Fahrenheit or Celsius, 0 degrees Celsius. So solid, liquid, gas. A gas. We know that 5th grade boys create a lot of smelly gas, right? Okay, all joking aside. So gas would be the air I'm breathing in, combination of gases, right? So the most important gas I'm breathing in is oxygen. I need that one. Then you have, when you boil water, it goes from a liquid to a gas. So matter can go from one state to the next at the end of the day. I'm going to fill my solid, my balloon, with a gas, smelly science guy breath, okay? Uh-oh, it's got a hole in it. Good thing I have another balloon over here. Okay, blow this one up. Let's see if it's got a hole. No. You think that's enough? Nah, it's not enough. How about that one? No. By the way, matter, we describe it by its observable properties. We don't eat our science experiments, but I can smell it, I can listen to it, I can look at it, and I can touch it. Okay, you think that's big enough? What do you think, Mr. Fraser?
No way.
You want it bigger?
Not
okay.
Bigger.
How about that? That's big enough. Okay. I'm going to tie a knot. This balloon is made of small pieces. The smallest unit of matter is called an atom. You put together atoms and you get molecules. So an atom is actually made up of smaller pieces. So the smallest piece of matter is a quark. But the smallest unit, because an atom has proton, neutron, electron, nucleus, is the smallest unit. So this is made up of small pieces. But hey, so are you. The balloon's made of small pieces. I'm made of small pieces. But your pieces are put together to create the coolest kid I know. The coolest kid that's going to create who knows what when you grow up. You could be the next president. You could be a lawyer. You could be a doctor. You could be a scientist. You could be a principal like Mr. Frazier. The list goes on. You have so much to offer this world. And I want you to know that I think about you a lot because you're awesome. You're a cool kid. Your pieces are obviously put together differently than a balloon. You're not a balloon. You're not made out of rubber, right? Okay, maybe Mr. Frazier's made out of rubber. Is he? No. Okay. So here's the deal. Oh, he is kind of rubbery, isn't he? Sharp skewer. I'm going to stab it through the balloon. Where do I go to keep it from popping? It's all about what a scientist does. They ask a question, they come up with a hypothesis, they design the experiment, they do the experiment, they collect data, they come to an ending. Okay, so where do I go? Where it's shiny? Or where it's dull. So where it's dull down here, the smaller pieces are holding hands tightly. They're holding on tight. They're saying, I don't want to let go. I don't want to let go. But here they're barely hanging on. So you go where something's barely hanging on or tightly hanging on? Tightly, right? So cross your fingers, pick your nose. Okay, don't do that one. We're going to try to stab it through here without it popping. Okay, here we go. Are you sure about this? Positive? Okay. Hocus pocus. Are you focused? Sure? Okay, eyes on the monitor. I'm gonna go through the bottom. I'll get a little bit closer. Push it through. Okay, the balloon's going through. The skewer's going through. Then I'm gonna go to the top where it's dark as well. I'm gonna use my fingernail to help puncture the rubber part of it. And I've skewered a balloon. Oh, there we go. Look at that. So the small pieces that make up the balloon are holding hands tightly around the skewer, keeping the air from seeping out. We just talked about pushes and pulls. Remember, what was a push or a pull? A force. What was a push or a pull? A force. Say it with me. A push or a pull? You got it. A force. So I'm going to try to balance this in the palm of my hand because I have the force. Do you agree? Let's try. There we go. Okay. I don't have the force, silly scientist. It's called balance forces. So we have gravity pulling down equally everywhere. We have air pushing against the sides of it. Try my nose. Hold on. Let me make sure I'm still in the monitor. I do have a big nose. Should work. Yep. Oh, hold on. A little bit. There we go. Oh, whoa. Okay. Here, you remove the skewer. Can you remove it? Oh, no, we're virtual. Never mind. Okay, so I'm going to take, is it going to pop? What's your hypothesis? You think it is? Thumbs up if you think it's going to pop. Thumbs down if you think it's not going to pop. Okay, here we go. Remove the skewer. And it didn't. Wow, look. And it still didn't pop. Okay, you're not watching a magic show. This is science. What's happening is those small pieces and the darker part of the balloon are holding hands super tight still, linking up so the air isn't coming out. What do you think might happen if I put it in the shiny part? Think it's going to pop? Are you sure? I don't know. You ready? Balloon's about to pop. Yep, there we go. It popped. Wow, pretty cool. Was that your favorite experiment, or did you like capturing your shadow? Or maybe the levitating ping pong ball? Pretty cool. Okay, time for you and I to do another science experiment. I think you're gonna like this one. This one goes back to energy, which is the ability to do work. There's potential energy and there is kinetic energy. Potential energy is stored energy. Kinetic energy is energy of motion. Think about a roller coaster when you are at the amusement park in the summertime. If you're at the top of the roller coaster, that's called potential energy, stored energy. And when you go down, you're converting potential energy to kinetic energy. When you get to the bottom, kinetic energy is at its greatest. Okay, so leave your stuff in your bag for now, but in a few seconds, you're going to get this out. I just wanted to elaborate on what you're going to find on this science sheet. And at hookedonscience.org, you're going to find all kinds of these for free. So that means you can take science beyond the classroom window or beyond our window that we're doing right here today. There's all kinds. The most recent one is creating an instant snowstorm. If you click on science guides or experiment archive, you'll find them all. But over here, you're going to find the science information that you need. So you don't have to be a scientist to be able to teach your kids science. Step-by-step instructions, as well as the ingredients there that you're going to need. And they usually use all of the ingredients from around the house. So this one focuses on pushes and pulls a little bit, as well as energy, as well as cause and effect and a lot of other things when it comes to the next generation science standards. So what I want you to do in a few minutes when you grab it, and this is important, so pay attention, okay? Flat tire. Shh. You're going to take the end of your dowel rod, take your pointer and your thumb and hold it tight, okay? Just like that. So go ahead and grab out your dowel rod and do this because we need to do this one together. I'll give you a few seconds. Go ahead and grab your dowel rod. And 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This comes from the side of a notebook. It's called a notebook spiral, okay? It's a plastic spiral notebook. This one takes you step by step on removing one from a notebook. Don't use the metal ones because these will launch across the room and we don't need a metal spring sticking out of anyone's arm or anything like that. So the plastic ones work best, okay? So what I want you to do next while you're grasping it, this is those fine motor skills, make sure you're grasping it. You're gonna take, let me get a little bit closer to the camera so that I can show you exactly what I'm talking about. You're gonna take and place your spring over the dowel rod, but make sure it doesn't go under your fingers. See how it's not going under my fingers because I'm grasping it really hard? Okay. Oh, good gravy. Okay. Icicle pump fell. Everybody got it? So what I want you to do next is we're going to store the energy. So this is stored energy. And then when I release it, it's potential energy. Did I just see some launch through their living rooms? I think I may have. No. Okay, good. Okay, so here's quickly, eyes on me. You're going to do it. So if we break this into 4 equal pieces, okay, 1/4 of the way, half of the way launch it, 3/4 of the way launch it. You can't go all the way, but almost a whole, okay? Which one's going to go the greatest distance? Will it be 1/4 of the way when you pull it all the way back? Will it be half of the way, 3/4 of the way or 75%, or almost 100%? So let me show you really fast what it does. 3, 2, 1. Just like that. Don't aim it at anyone's eyes, face, or the pet either. Don't aim it at the dog, the cat. Maybe you have a pet giraffe at home. I don't know. Don't aim it at the pet giraffe. Got it? Anybody have an elephant at their house? How about an opossum? Cat? So I want you to try this. We're trying to figure out, will it go the greatest distance 1/4 of the way, half of the way, 3/4 of the way, or all the way? I'll let you launch down a little bit. Make sure that you're launching them not at anyone's face, but toward the ceiling, wherever you have to go to make sure you're not getting it at anyone's face, okay? We got to make sure we're safe with it. So again, you're storing energy. Potential energy is stored energy. Kinetic energy is energy of motion. So once it launches through the room, that is called kinetic energy. Kinetic energy, and it goes pretty far. I'm going to let you play around with this for just a little bit. At the very end, we're going to have some questions, so you be thinking about questions. I know that Mr. Frazier is going to kind of put those together that you might have, and we'll see who has any good questions. They start with who, what, when, where, why, how. We're not looking for a story, but a question. Good question.
I'm monitoring the chat right now, so students or parents, if y'all want to throw a question in the chat box, and we'll be sure to ask that, depending on how many they are.
Yeah.
I hear my daughter is in the other room. She's watching this live, and I can hear her launching her spiral right now. So
she's not launching it at her dad.
That's why the door's closed.
That's funny. That's funny. What grade is your daughter in, Mr. Frazier?
She's a preschooler.
A preschooler. Pretty cool. Raise your hand if you're in kindergarten. Oh, wait a minute. I'm not kindergarten. Raise your hand if you're in first grade. Second grade? Any third graders out there? Fourth grade? Fifth grade? Sixth grade? Okay. I would like to go back to, what grade would you go back to, Mr. Frazier, if you could go back to school? What grade would you go back to?
I would go back to, I think, the sixth grade, because for me that's when I started band, and music was a really big part of my life, and so that was a really fun time because you started band in sixth grade.
So what instrument did you play?
I'm a clarinet player.
A clarinet? See, I didn't play any instrument at all, but that'd be cool. Are you good at it? You have your clarinet there? You want to play for us?
It's put away right now. My chops are lacking
Frazier.
right now.
I'm trying to get you to play some music for us.
Oh, yeah. I don't want to. We got 60 people watching us right now, and I don't want to turn that into 2 people real quick.
Okay, it's time for us to clean up from that experiment. While it doesn't make a big mess, by all means, I do want you to go grab your spring launcher and place it back into your bag. So put everything back into your bag, zip it up. Remember, you can do these experiments at any time. The one was all about pushes and pulls. If you're just joining us, you have your straw, you're blowing through your straw. With a greater force, it's going to go higher. With a not so great of a force, it's going to go lower. Air's pushing up, gravity's pulling down. Where they balance out is where they float into the air, where the ball floats into the air. And the other one, we stored the energy, we pull it all the way back, and then when we launched it, it launched out across the room. Pretty cool. 2 experiments that you can continue to try. We captured a shadow, and we still got one more experiment, and then bunches of questions that you might have. This is one of my favorite science experiments. I grabbed this from the living room when no one was looking, so hopefully no one will notice. And then I filled a balloon full of baking soda and vinegar. It's all about matter. Okay, we'll refocus. Everybody back on your bottom, hands in your lap, eyes on me in 5, 4, 3, 2, 1. So matter is anything that takes up space and has mass. It can exist in 5 states, as we talked about. We're really going to focus on 3, especially here, because we have a solid, which is called baking soda in here. What do you use baking soda for? You can use it to brush your teeth. You can use it to clean things with. Some people put it on their face to make it look more beautiful. I don't know. Ask your doctor before you do any of that. Either way it goes, it's used in a lot of ways. Inside of here, anybody drink vinegar? No. You might put it on your salad. I don't like a lot of vinegar. It smells bad. But either way it goes, I got vinegar in here. It's probably about, see there, a quarter of the way. Would you agree? If I were to break that into 4 equal pieces, that's one of the pieces, maybe a little bit more. And then I filled the balloon up with as much as I could with baking soda. When you mix matter together, sometimes you get something new, something that you didn't have before. We call that a chemical reaction. Now, let's think about a cake. What's your favorite cake? Pineapple upside down cake, chocolate cake, vanilla cake, list goes on. There's all kinds of strawberry cake, mud cake. Is that good? What about mud pie? You like mud pie? Skunk cake? That's delicious. Okay. All joking aside, you have to have all these ingredients. You put them inside of a bowl, you mix it up, then you put it into the oven and you cook it. And while it's cooking, you smell. Remember, I told you, it's a chemical reaction if you use your senses to describe it. So I can smell it. I could hear it cooking sometimes, bacon on a stove frying, for example. I can see it change. It's going from a liquid to a solid. And then in this case, while it's not science class, I can eat the cake, right? Yeah. So, and I would taste the cake. What if I cut the cake into many pieces? Is it still cake? It is. So that's a physical reaction. Now, baking the cake is a chemical reaction. We are about to mix together baking soda and vinegar to create a chemical reaction. And that chemical reaction is we're going to further describe it by, is it hot or cold? If it gives off heat, we call that exothermic. So let's dissect the word. Thermic is heat, exo is outside. Hand warmers give off heat, they're exothermic. But then the opposite of up is down, the opposite of potential energy is kinetic energy, the opposite of chemical reaction is physical reaction, the opposite of exothermic is endothermic. Thermic, heat, endo, inside. So we're going to create an endothermic reaction. It's going to get cold on the jar here. So let's mix everything together. As a result, we're going to get a gas. So I'm mixing everything together. Oh no. You hear it? It's fizzing. It's bubbling. I'm hoping it's not going to explode in my face. There we go. I think we're good to go. Yep, we're good. It's not exploding. And that is called the expanding balloon. Thanks to a chemical reaction, we were able to create the expanding balloon. Inside of the jar, I see a change happening. The jar is cold, super cold actually, endothermic reaction. And then I had a gas that filled up my balloon. So all things proving that a chemical reaction was happening. Sometimes the balloon launches off, but I mixed the ingredients just right so it didn't launch off. I didn't want to create a big mess here. Not at all. What you think about that one? Was that one fun? I like this one too, but my favorite still is capturing your shadow. Capturing your shadow, being able to do that is pretty fun, and you can do that experiment as well. Okay, so we did multiple science experiments today. Everything from you helping me do 2 experiments, making a ping pong ball float in the air, to launching a spring across the room. We captured a shadow, we skewered a gigantic balloon, and we filled a balloon with a gas. We call it the gassy balloon. Question is, do you have any questions as we start to wrap up everything? Anybody have any questions out there? Kind of starts with who, what, when, where, why, how. Not a story, but a question. Anybody got me a good question? Have you got any good questions, Mr. Frazier?
We have not got any questions yet. We have had some people who are laughing at your jokes. Miss Keller, I think, was slapping her knee on some of your jokes earlier.
Oh,
And
so I should be a science comedian.
I
Wow.
think so, yeah. And Miss Beals and Miss Metter were just saying how cool some of these experiments were. I think we
Yes.
just had a lot of people who were just so focused and participating so much they didn't have time to type their questions in.
We've been doing this virtual stuff for a long time now. I guess we've all adapted to it. But
Yeah.
we know the best way to learn science is hands-on, which is why you had your bag of science here. Let me see what's in my crate over here. And see if there's anything else that I can do. Oh, yes. Let me show you this really fast. This is an experiment you can try, and I want you to take pictures of it and post it there on the Facebook page. And let me know how it goes. So basically, you can create your own hand warmers. What I have here is something that you get. I got this at Walmart. Okay. Basically, you put it on. It's called pet-friendly ice melt, but it's got something in it called magnesium chloride. Obviously, you don't want to just open this up and drink it, duh, right? So make sure that you're not putting it in your mouth or your eyes or your nose. But mom and dad, not kids, can pour some of this in a sandwich bag, and then when you add some water to it, zip it up, make sure it's zipped up. It gives an exothermic reaction, and you create your own hand warmer. So when you're doing that at home, let's pretend like this is my bag. I pour it in there. Let's say we put half a cup in there, and then 1/4 of a cup of water. So if I use a whole cup, then I put a half a cup of water. You see how I'm doing that? So if I put it in there, I'm going to make sure before I zip it all the way up, I'm going to push the air out of it like that. And then I'm going to zip it up. And then I'm going to fold it so that I have my very own hand warmer. So a lot of people don't know that. So let's say you're stuck in the snow or you're out and about in the middle of nowhere and you have some of this in your car, you can create your very own hand warmers. I don't know about you, but I bought some of those hand warmers and you have to unwrap them and you have to rub them together forever to make sure that they work and keep rubbing them together and so on, so that they eventually work. And then like the next day, it's like, oh, it's warm. Like many hours later when you really don't need it. This acts immediately. So make sure you grab some of this and you can create your own hand warmers, but make sure it has magnesium chloride or calcium chloride. There's 2 different ones. Just don't ingest it or anything like that. And it says it's pet friendly, but don't let your dog or cat lick it either way it goes. But it's a neat way to mix some ingredients together to create your very own hand warmer overall at the end of the day. Any other questions come in?
Nope. The crowd is silent right now. I think they were doing such a great job listening. But so I have a question about the board. So is that just a glow-in-the-dark paint that you can find anywhere, or is it a special type of paint? Or
Well, the glow-in-the-dark paint you can buy at any hardware store. You can get it at Walmart, Target. You can get it at your craft store. You can get it at Lowe's, Home Depot. They'll even bet you out. I don't know. You get the point. You can get it just about anywhere in the paint aisle. But make sure you paint your board multiple times. This here is a vinyl sticker. And that vinyl sticker, basically, you can buy online. I got mine at teachersource.com, and you can buy them in different sizes. But it seems to work the best. Again, let me turn off the light, and I'll show it to you one more time so that you can kind of see how fun this one is. You notice it's already glowing because of the light in the room, but there it is, my board. I'm going to take my bright flashlight. It's no special light. I'm going to kind of erase anything that was on there. I'm going to put my hand on here, bright light on here. Then I'm going to remove my hand. It's kind of a spooky experiment. It's almost like a Halloween experiment. And then I can place this on here, and I'm now Iron Man. Isn't that pretty cool? So this is a simple one. I just make this small so that I can carry it around. But like I said, you can paint a classroom. Maybe Mr. Frazier should allow all of his teachers to paint a classroom wall in glow-in-the-dark paint. Maybe
that
not.
Sounds fun because we often turn all the lights off in our classrooms a lot. So it
Do you
would come
take
in
naps?
handy,
Is
wouldn't
this
it?
like preschool? When I
Maybe a
was in
little sarcasm
kindergarten
there.
at Richardsville Elementary School many years ago, back in the middle 80s, we went to kindergarten half a day. We slept, ate a snack, picked our nose, went to outside, and recited our ABCs. Now, from my understanding, you're multiplying and dividing before you leave kindergarten now, right?
Oh, they're doing algorithms now. I mean, it is intense.
Yeah,
Well, we have a question in now. Paisley Webster wants to know. She's going back to the ping pong ball and straw experiment. And
Yes.
she wants to know what should be easier, either putting the ping pong ball on the end of the straw and then blowing, or blowing first and then letting go of the ball.
What did she discover?
Well, she did not say that. She just put the question in there.
That's a good question. I'm glad she's thinking. That tells me that she's thinking like a scientist. So one of her suggestions were placing it on and then starting to blow. Let's test it. Okay. She said place it on first and then blow, right?
Yep.
That didn't work for me, at least. Or do I start blowing through the straw and then place the ping pong ball on? That was the other one, right?
Right.
For me, that way works better. But that may not be the case for everybody. I mean, everybody does things differently. That's what makes us all unique and different. We do it differently. Something for you may work differently for me. And if it's working for you and you're succeeding at it, awesome. Continue to do it that way. But this way first didn't work so well for me. Well, it did that time. But then put it on there. Or put it into the flow. I guess either way. So Paisley, what was best for you?
She thinks both are hard.
She thinks both are. Does she have a different?
Sounds like she needs some practice with it.
I have a challenge. I did the short end up straight up. Why not do the long end? Will that make a difference? Let's try it. I made it work the same way. You just have to blow a little harder. How'd you work?
I found that easier for me.
Did you find it easier for you?
That was easier having the long end going up
into the air. See there? Yeah. This is what science is all about. We try it many different ways. And as we try it many different ways, we eventually come up with the best solution at the end of the day. And sometimes that may work for a while, and then we try something else, and then we change it up yet again. So, yeah, pretty cool. Awesome. So I just want to remind you, don't forget to go post your pictures of your kids doing those science experiments. I need to snap a picture really fast so that I can post it. I'm going to post it right here in just a second. Let me grab
While you're snapping your picture, Avery Fugate wants to know how long that orange balloon will stay blown up if it's just left on the bottle.
Have you ever been to a fair and you brought home a balloon and like the next day it went flat? So here's the deal. This balloon, while it looks like it's sealed up, there's still tiny little holes in it. So I would give it a week and it will probably go down. Not only because there's tiny little holes in it that we can't see, but also it's going to seep out air along the bottom as well, unless I tie it. Now, if I tie it, it may stay a little longer. But because there are tiny little holes in the balloon that you and I can't see, it's a little bit, let's see here. I'm going to do this and get my, is Mr. Fraser in there? Oh, yeah, that's right. You're Mr. Fraser, aren't you? I work with too many principals.
Still am.
There we go. Perfect. Got it. Okay, awesome. I'll use that. Look for that picture on my social media and post your pictures and your comments with that if you don't mind, please. And that'll enter you into the drawing for my free science book that it just came out in October, I think, or was it September? Recently in the fall, called Big Science Experiments for Little Kids. One of my favorite experiments is in there is putting ivory soap in the microwave. You know, ivory soap is a soap that floats. It always has. The company claims that they purposely did that. Others say it was by accident. Either way it goes, ivory soap, again, key, ivory soap. If you drop it in the bathtub, it'll float, and it's because it's filled full of air. So what happens to that air when you place it in the microwave? Wonder what happens to the soap. Don't put soap in the microwave unless there's an adult around, kids. But it will do something unique. I'll give you a hint. It might look like meringue on a pie. But don't eat it. Don't eat soap at all. It will cause some issues with your digestive tract. You might have dino diarrhea. Don't do it. Any other questions, Mr. Fraser?
That's it, but we appreciate you giving us a copy of your book that we can put in our library. So we've got that book that'll be going into circulation with us.
Oh, cool. I'm working on my third one. It has to do with weather questions because what kind of scientist am I? I attempt to predict the weather on TV. I'm a traveling meteorologist, so I visit different stations as meteorologists are out. I actually graduated from Western Kentucky University a long time ago, back in 2000. Well, that's 22 years ago, isn't it? With a degree in meteorology and journalism, and then left TV in '07 to start my own business called Hooked on Science, which you've seen me do science on the local TV station and everywhere else. Either way it goes, when it comes to the scientist I am, I'm a meteorologist. So I've received tons of questions for my first TV job in Hopkinsville, Kentucky. Like, will a tornado cross a river? Will it cross a lake? Does the sky turn green during a tornado? You know, different questions like that. So what I'm doing is I'm writing my third book, which will be out in 23, in the fall of 23, that will answer science weather questions that I have received over the years with a science experiment. So, and that uses ingredients from around the house. So that'll come out in 23, fall of 23. But it'll be wild weather questions. So look for that one. But in the meantime, lots of free experiments at hookedonscience.org. I'm trying to think if there's anything else I need to tell you. I think that's it. Can't wait to see you students in person. I think we have something on the schedule for February. Is that right?
Yep, we're going to be bringing you, we don't have all the details worked out yet, but we're going to be bringing you into Plano. Hopefully we're all going to be back in Plano soon. But yes, we will. We're looking forward to bringing you back.
Are you the principal we're supposed to catch on fire while we're there?
Oh, no, that was Miss McKinney.
Okay. Is that your assistant?
Yes. We'll set her on fire.
Okay. She won't mind at all. Not at all. Yeah.
All right. Well, Mr. Lindsay.
Yeah. Okay.
Well, Mr. Lindsay, thank you so much for joining us. And students, thank you. We had up to 60 people join us tonight. If you want to go back and watch it again, you can just visit the same link and you'll be able to watch this show again. So thanks a lot. Everybody stay safe. Students, we do have another NTI day tomorrow, so make sure you're logging into your Google Classrooms, and we'll see you then. So everybody, take care.
Keep safe.